All right, welcome back. We are now going to look at some examples with compound interest, but let's first just describe it once again just to make sure we understand. So in general, compound interest calculates interest at specific points throughout the overall period of time. At these points in time, the new principal is based on the principal plus the interest earned up to those points. In doing this, it increases the overall amount of money to be paid back or that is accrued. So compare the future values using simple and compound interest for a $1,000 deposit at 4% interest for 5 years. So again, we want to look at those future values. So we got A is equal to the $1,000 times 1 plus RT. So 0.04 times 5, and let's see what we get. So we got 0.04 times 5 equals that, plus 1 equals that, and then times the 1,000 equals $1,200. So $1,200 is what you would get if you deposited $1,000 under these stipulations. So you get $1,200 after that 5 years. Now, if we compound the interest, and here I'm going to just compound it annually, but there's going to be other ways we can compound it, which we'll see on the next page. What that does is we're going to, like I said, we're going to compartmentalize the interest at every year throughout those 5 years, and that's going to actually make it a little bit more. So let's see how that works. So we got A is equal to 1,000 to start with, and we're going to use the simple interest formula, but we're only going to do it for 1 year. So if we do it for 1 year, now we should get $1,040, but let's just double check it. So we got 0.04 times 1, which is 0.04, so I'm not going to do that, plus the 1 equals that, and then times the 1,000. So we get 1040. So after 1 year in that 5-year lifespan, it's already bumped the principal, the new principal up for the next year up to $1,040. So that's what we're going to actually take and put here. Now, this can be a very lengthy process if you have a lot of years and you have a lot of compoundings. We're just doing it once per year, but we might compound it even more often than that. So that would mean a lot more individual calculations, which we don't want to do. So we're going to see how to do it a little bit faster in a second, but let's just keep going with this one. So we have the 1,040 again, and then we want to multiply that by, remember this is just 1.04. So let's just times it by 1.04, and so we get $1,081.60. All right, so again, we're going to carry this as the new principal for year 3. And so 1 plus 0.04, oops, times 1. So same thing, we can just carry this and then times it by 1.04 again. So now we get $1,124.86 if we round that. All right, so I'll carry that for year 4's principal. I'm just going to say 1.04. So now if I leave this whole thing in there, that's probably going to be a little bit more precise. So let's not. Let's use the rounded version and see what, if anything, happens. Okay, so times that by 1.04. So we get 1169.85. And now we can use that for the last year. So 1169.85 times 1.04 equals $1,216.64. So in this case, by compounding it annually, we've actually increased the bottom line. So here we only made $1,200, but here we made $1,216.64. Now it doesn't seem like a lot because it's not really a large amount of money. But if you said that this was $1 million, well, then you're making a little bit more money off of that. So it's something that is obviously benefits if you have larger sums of money. But the bank uses this as well because sometimes they'll want to get more money out of you. So when they do a loan. Okay, but this is the long way to do it. We don't want to have to do 5 steps or more than that even, depending on the problem and everything else. So we do not compound interest this way moving forward. There is a formula. So let's take a look at that. So, in general, compounding can be done annually. So basically one time every year, which is the way we just did previously. Semi-annually, which is basically twice a year. And then quarterly and monthly and daily. So quarterly is 4 times a year, monthly is 12 times a year, daily is every single day. So in order to do this effectively, we just have to make sure we understand how these pieces are linked. So let's just take a look here. For the upcoming formula, we will use this information to determine how many compoundings per year is happening, which is basically based off of this phrasing. It's going to be one of these 5 phrasings, as well as the total number of compoundings that occur for a given problem. So if I said quarterly over 3 years, that means there's 4 compoundings per year, which we said before. Quarterly is 4 over 3 years. So when we multiply those together, we get a total of 12 times it was compounded in the life of that loan. Monthly over 4 years. So monthly would be 12, but then times the 4 gives you the 48 compoundings throughout the whole life of the loan. So those are the 2 important numbers we're going to need to find. So let's see how we can do that kind of easily in this formula. So future value for compound interest. So P is still our starting point, our principal, and our deposit at the annual interest rate of R. So R is still our interest rate. We still want to change it to a decimal. Compounded M times per year. And the money is left on deposit for a total of N compoundings. Then the future value A, the final amount of the deposit, is calculated as follows. So we got A equals P, parentheses, 1 plus R over M, all raised to the N power. Oh boy. Now, we can make life a little easier for us if we multiply M times T to get N. But the only condition, remember, is that T's got to be in years. So we got to be careful when it's not. All right, let's try a couple of problems here, and then we'll see how it goes. All right, so find the future value for each deposit, blah, 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 blah. Okay, so again, we know this is P, we know this is R, we know this is T, and then compounded semi-annually. So remember, semi-annually means 2 times per year, but what variable is that? The only variables we haven't identified are M and N. In this case, it's M. So M equals 2. Now that we know what M is, we can figure out what N is. So that means that N is equal to 2 times 6, which is 12. So now we have all the pieces for our formula. So we got A equals 700 times 1 plus R, so 0.03, over M, which is 2, raised to the 12th power, which is our N. Okay, so now why did you need a scientific calculator is because of that exponent. We want to be able to put in larger exponents, so you need to have a scientific calculator minimally. If you have a graphing one, that'll do the trick as well. but a scientific one is all you really need. So, okay. Now, we should follow the order of operations. So the first thing we should do is take care of what's in the parentheses first. So inside of that, we want to divide before we add. So order of operations pretty critical here. So 0.03 divided by 2 equals that, plus the 1. So that's what's inside the parentheses, 1.015. Now we should take care of the exponent, the 12. So how you do that on this calculator is this button right here, yx. So if I hit yx, nothing really happens. But if I hit 12 and then equals, that is going to give me this large yucky decimal. Now, if you wanted to write that down, you can, but I would just leave it in your calculator because the next step is just to multiply by the 700. So just times that by 700, and there's your answer. So 836.93. Now remember, if this had been a 5 or a 6 after the 3, we would have rounded that up to 94 cents. So don't just chop it off, round it up or down depending on what the third digit is here. So be careful, don't be lazy. All right, let's try another one. So we got A is equal to what? So we can start filling in a lot of this stuff here. So we know the 2500 is our P. We got a 1 plus our interest rate, which is 0.02 over what? So we need M. Compounded daily means that M is equal to how many days in a year? Yeah, 365. So 365, which means that N should be equal to what? M times T. So M is 365 times T, which is 3. So what does that equal to? Well, it looks like 1095, I believe. So, so we got a really huge exponent. So M is on the bottom, and N is the exponent. All right, let's see what this does. All right, so start with the fraction. Now, if you have a scientific calculator or a little bit fancier scientific calculator, a graphing calculator, or a little bit fancier scientific one, you might be able to get away with just typing this whole thing in on one line. But this calculator is fairly simplistic, so you really should kind of work, backwards or using the order of operations. So, and if you have a different scientific one that you would like to know how to do that, just send me an email and I can let you know. 0.02 divided by 365 equals that, plus 1 equals that, and then we want to raise it to the 1095, which equals that, and then times it by the 2500. So we get $2,654.59. So $2,654.59. Okay. Well, we are at the 14-minute mark. So let's stop here and we'll pick up some more of this, but this next problem is a little bit different than what we've been seeing. So you'll want to watch that for sure. See you in a minute.